Hello class, today we're taking a look at the comparing rates practice, and we know that a very useful application of unit rates is to be able to compare two items in a fair weight using a unit rate. The reason a unit rate is a fair comparison is because it makes our different situations be comparing to the same thing. So in our guided practice, as an example, when we make a unit rate for 1 liter on the bottom, then we can fairly compare how much 1 liter of either option is going to cost us. So let's take a look at this problem here. We're told to use unit rates to compare each option. Option 1 tells us that we have $2.25 per every 4 liters. And to make a unit rate, we always divide by the number on the bottom. So dividing by 4 on the bottom, 4 divided by 4 gives us our 1 liter unit rate on the bottom. And then we can do our 2.25 divided by 4 on top to get 0.5625 for our top. And so our unit rate for option 1 is $0.5625 per liter. We can do the same thing in our option 2. So we have 5 liters on the bottom. We want to get to 1 liter. We're going to need to divide by 5 in order to do that. Of course, if we divide the bottom by 5, we'll divide the top by 5 as well. So we'll do our 2.85 divided by 5, and we'll get our 0.57. And we can say our unit rate is $0.57 per liter. Now that's our calculation work to compare. We now have two fair unit rates for us to compare. And whenever you're using a unit rate for comparison, you need to be able to justify, is a higher number better or a lower number better? So this means that we spend 56 approximately cents for every 1 liter of whatever we are buying. Whereas in option 2, we're spending 57 cents for every 1 liter that we're buying. So since generally people want to spend less money, we'll say option 2 is better. And that is our, actually option 1 is better because we do want a lower unit rate. And so in our explanation, we'll explain because it costs less money for the same 1 liter of whatever you're buying. So that explanation is really important because, of course, if we had done liters per dollar, we'd actually want the higher number unit rate. We'd want more liters for the same $1. So we can do that same process all the way through these next 4 problems in our practice. So let's go ahead and compare store A and store B. In store A, we have slices of cheese and money. So I'm going to put slices on top and money on the bottom. Of course, it doesn't matter. We are told that 10 slices of cheese at store A cost $2.48. And of course, as always, we divide by the number on the bottom to get our unit rate. And so we'll do our 10 divided by 2.48, and we'll get our 4.03 slices. And so we could say that this is 4.03 slices per dollar. At store B, we want to keep our same setup, so we need to still have slices on the top and dollars on the bottom. We have 12 slices at store B for $3.18. And as always, we're going to divide by the number on the bottom to get our unit rate. And 12 divided by 3.18 gives me 3.77 slices. And so I can say 3.77 slices per dollar. So which one is better? Do we want to get 4 slices for every dollar that we spend, or do we want to get 3.7 slices for every dollar that we spend? Well, we want to get more slices for the same amount of money. So we'll say store A is better because you get more cheese for the same $1. Let's take a look at question B. We can do the same type of idea with store A, store B, and our explanation. So let's go ahead and do our dollars and our cookies. Store A tells us that we spend $298 for 15.5 ounces. And so we'll want to get a 1 on the bottom there. So we'll divide by the number on the bottom. We'll get our 1 ounce on the bottom, and we'll do our 2.98 divide by 15.5, 0.19225 dollars per ounce. And let's do the same thing in store B. So again, we got dollars and cookies. We are starting with $2.50 for 14 ounces of cookies. We'll divide by the number on the bottom. 14 divided by 14 is 1 ounce on the bottom. And 2.5 divided by 14 gives us 0.17, let's say $9. So $0.179 per ounce. So since we use dollars per ounce this time, I want to pay less money for the same 1 ounce of cookies. And so 0.17 is less money than 0.19. So I'll say store B is better because you pay less money for the same 1 ounce of cookies. And you would use the similar process for questions C and D as well. Let's take a quick look at the back side. So these are also comparison questions, but these are ones that are in a little bit of a different style. So I've got question 2, a teacher marked 15 exams in 34 minutes. Can they complete their entire set of 102 exams in 3 hours and 45 minutes? We want to show our work and explain how it supports our answer. So there's 2 possible methods here. We discussed these in class. One possible method would be to use our unit rates. And in this case, we want to compare what we are able to do with what we need to do to complete the task. So I'm going to compare exams and time in each of these. And so let's go ahead and say in our what we're able to do, we are able to do 15 exams per 34 minutes. And we'll go ahead and divide by the bottom number there. And in 1 minute then, we are doing 15 divided by 34, gives us 0.44 exams. And then in what we need to do 102 exams in 3 hours and 45 minutes. So 102 exams, and then 45 minutes is 3/4 of an hour, so 3.75 hours. Now, we'd actually want to not use hours here since we used minutes over here. So let's go ahead and take our 3.75 hours. And we'll times our 60 minutes per hour. And that's going to give us our number of minutes. So 225 minutes. And again, we'll make our unit rate by dividing by the number on the bottom, which is 225. Get our 1 minute on the bottom over here, and 102 divided by 225. Oops. 102 divided by 225 gives us 0.45. So how does this answer our question? We're going to say no. they cannot mark those exams in 3 hours and 45 minutes. The rate they are able to mark is less than the rate they'd need to mark at. Right, we're only able to do 0.44 exams every minute. We need to do 0.45 exams every minute. So obviously very close, but we would not be able to mark all the exams in that 3 hours and 45 minutes. Now, the other way to do this is to calculate the time that you'd actually need to do your 102 exams using a proportion. So we'll set that up. We'll still use exams and time. Our rate is 15 exams, takes 34 minutes. We want to do 102 exams and know how many minutes that will take. I'm going to use cross multiplication to complete this. So we'll say that 15 times question mark is equal to 102 times 34. We'll divide both sides by question mark, and we'll say question mark equals 102. We'll divide both sides by 15 to get it away from the question mark. And we'll do our 102 times 34, divide by, 102 times 34, divide by 15. Still missed the 34. 102 times 34, divide by 15. That's better. Typing is hard sometimes. So we would need 232 minutes, or 231.2 minutes, which is obviously a lot more than the number of minutes we have. We only have 225 minutes, you need 231. So again, obviously you're not that far off, but it would take you too long to mark your 102 exams. So I hope that's helped you understand some of the ways that we can solve problems where we use a unit rate to compare two values.